of 2, because log 2 of 2 we know equals 1. So that's what I'm going to do, and I know I've done it here, but I've written that plus 1 as log 2 of 2. Any questions there? The reason I've done that, because now all of them are log base 2. And because they're all log base 2, before I can put them together, and get rid of the logs, I should say, I need to put these two together because they're on one side of the equal sign. And log 2 of 3 to the power of k plus log 2 of k of 2, when you're adding, we times these two together. So we're going to get log 2, 3 to the power of k times 2. Now I can get rid of the log 2's because they're both log 2's on both sides, left-hand side of the equal sign and right-hand side of the equal sign. So we get 6 equals 3 to the power of k times 2. Divide by 2, so I'll get 3 to the power of k equals 3. And k here equals 1, because that's 3 to the power of 1 there. So just by equating gives me k equal to 1. Any questions there? Now my pen works. Any questions there? Right, example 24. It says solve for x if 2 to the power of x equals 11. Express the answer to 2 decimal places. Well, there's our x as a power. The only way to get rid of this base 2 is to take log 2's. We can use that change of base rule, right? But you should know if we've got 2 to the power of x equals 11, log base 2 of that and log base 2 of this, these will cancel and we'll get x equals log base 2 of 11, which is what I've got up here. Then all you need to do is get your calculator out and work out log base 2 of 11, and it says correct 2 decimal places, so 3.46. Any questions there? Okay, I'm going to give you guys a little bit of time to start this, at least if you don't finish it, it won't matter, but to start this to see how you would go about tackling this question. And it's not hard. Okay, the first thing I always look at is to see if I can get this number here, the 28, as a 3 to the power of something, and I can't, because if I could do that, then I'd just equate the powers. I can't do that, so the first thing I'm going to do is take log 3's, because I've got to get rid of that base 3. And you don't have to write this line. Oops. Okay, you don't have to write this line that I'm writing right now, log 3 of 28. You can get rid of this automatically and just write 2x minus 1 equals log 3 of 28. So I will skip this line completely. Then, of course, to get x, I'm going to add my 1 and divide by 2. So x will equal log 3 of 28 plus 1, all divided by 2. Okay, so any questions? And it says to 3 decimal places, so we'll have to work it out. That's a 1 there. So I better get my calculator out, unless someone's done it. Has anyone done it yet?
2.017.
2.017 is correct. 3 decimal places. Okay, any questions on that one? Okay, I'll clear this. You can, of course, do it on your calculator. All we're doing is solve, just put it into your calculator, comma x, and of course it gives it to us. If you want to do it as decimal place, just remember, go Control Enter before you press Enter. All right, example 26. Solve the inequality 0.7x is greater than or equal to 0.3. Again, the same thing applies here. We're going to take, and I didn't write it in, but I'll write it in here, log of 0.7 of 0.7x is greater than or equal to log 0.7 of 0.3, because these two we can't make it as 1, so we just get x here is greater than or equal to log 0.7 of 0.3. And then just get your calculator out and work that out. It doesn't tell us to how many decimal places, that's why I've left it as x is greater than or equal to log 0.7 base 0.7 of 0.3. Any questions on that one? Okay, you don't have to do it as 0.7s. Okay, I'm going to show you another way, and this way might be even better. Okay, I'm going to take log 10s because our calculator is log base 10. So I'm going to do it as log base 10 of 0.7 to the power of x is greater than or equal to log base 10 of 0.3. And this might be better, that might be wrong actually, when I come to think about it. So the x now comes at the front. So this power comes at the front. So I've got x log base 10 of 0.7 is greater than or equal to log base 10 of 0.3. And now, because that's a times between the two, I'm going to divide log base 10 of 0.7. So x, I'm not going to put greater than or equal to just yet. Log base 10 of 0.3 divided by log base 10 of 0.7. What I really need to know is log 10 of 0.3, is that a negative number or a positive number? Because if it's a negative number, then this has to change direction. So I need my calculator. Pretty sure it's a negative number, but I'm going to double check it. Log base 10 of 0.7 is a negative number. So that means I'll have less than and equal to that. And I can, of course, write it as log, I better write x again. I'll write it up here. X is less than equal to log base 10 of 0.3 divided by 0.7. If they wanted it to 2 decimal places or whatever, we'd work it out to 2 decimal places. So my previous answer is actually wrong. Any questions on that one?